Greetings, curious humans! Welcome back to another exciting episode of our cosmic journey. Today, we set our sights on a planet that has captivated the imaginations of astronomers and dreamers alike, Neptune, the mysterious ice giant of our solar system. Neptune, named after the Roman god of the sea, is the eighth and farthest planet from the Sun. It lies about 4.5 billion kilometers away, making it the most distant planet in our solar system. This azure blue giant is the fourth largest planet by diameter and the third most massive, dwarfed only by Jupiter and Saturn. A truly enigmatic world, Neptune holds a wealth of secrets waiting to be unveiled. Its gaseous atmosphere is dominated by hydrogen and helium, with just a touch of methane, which gives it its brilliant blue hue. But beneath those swirling clouds lie some of the most ferocious storms in our solar system, including the infamous Great Dark Spot. As we embark on this celestial voyage, we'll delve into Neptune's fascinating history, its unique characteristics, and the latest discoveries made by space missions and powerful telescopes. We'll explore the tantalizing mysteries of its icy moon Triton and discuss how this icy giant compares to its sibling, Uranus. So, whether you're an aspiring astronomer, a space enthusiast, or just someone seeking a deeper understanding of our incredible universe, join us on this cosmic adventure as we unravel the wonders of Neptune, the majestic ice giant at the edge of our solar system. Don't forget to hit that subscribe button and ring the notification bell to stay updated on our cosmic explorations. Now, let's set sail into the depths of space and explore Neptune, the mesmerizing gem of our galactic neighborhood. Neptune, the eighth planet from the Sun, holds several distinctions in the solar system. It is the farthest known planet, the fourth largest in diameter, and the third most massive planet. With a mass 17 times that of Earth, it is slightly more massive than its near twin, Uranus. Neptune's composition of gases and liquids gives it no well-defined solid surface, and its atmosphere is denser and physically smaller than Uranus due to gravitational compression. Discovered through mathematical prediction, Neptune's existence was hypothesized by Alexis Bouvard, prompted by unexpected changes in Uranus' orbit. Independently, John Couch-Adams and Urbain Le Verrier predicted Neptune's position from Bouvard's observations. On September 23, 1846, Johann Galle observed Neptune through a telescope, confirming Le Verrier's predictions. The planet's distance from Earth makes detailed observation challenging, but Voyager 2's flyby in 1989 and advanced telescopes have provided more insights. Like Jupiter and Saturn, Neptune's atmosphere is primarily composed of hydrogen and helium, but it contains a higher proportion of ices, such as water, ammonia, and methane. Its blue appearance is due in part to traces of methane and thinner haze in its more active atmosphere than Uranus. Neptune's atmosphere is significantly more dynamic than Uranus, featuring active and visible weather patterns, including dark spots comparable to Jupiter's Great Red Spot. It boasts the strongest sustained winds in the solar system, with speeds reaching 2,100 kilometers per hour. Neptune's great distance from the Sun results in extremely cold temperatures in its outer atmosphere, while its core experiences high temperatures. The planet also possesses a faint and fragmented ring system discovered in 1984, labeled as arcs. In summary, Neptune is an intriguing ice giant with a mysterious and dynamic atmosphere, characterized by its active weather patterns, striking blue appearance, and extreme climatic conditions. The earliest recorded observations of Neptune were made by Galileo Galilei in December 1612 and January 1613. He mistakenly identified Neptune as a fixed star when it appeared near Jupiter in the night sky. However, he didn't receive credit for the planet's discovery because he didn't recognize its motion relative to the fixed stars. In 1821, Alexis Bouvard noticed discrepancies in the orbit of Uranus, Neptune's neighbor, which led him to hypothesize the existence of an unknown planet perturbing Uranus' orbit through gravitational interaction. In 1843, John Couch-Adams began working on the orbit of Uranus, and independently, Urbain Le Verrier also developed his own calculations. James Shellis attempted to find the planet in 1846 but failed to recognize his observations as Neptune due to outdated star maps and poor observing techniques. On September 23, 1846, Johann Gottfried Galle, following Leverrier's predictions, discovered Neptune near Iota Aquarii, confirming its existence. There was a nationalistic rivalry between the French and British over credit for the discovery, but an international consensus eventually recognized both Leverrier and Adams as deserving joint credit. In later years, some historians questioned Adams' claim to co-discovery, but the issue was re-evaluated in 1998 with the return of historical documents known as the Neptune Papers to the Royal Observatory, Greenwich. In summary, Neptune's discovery involved multiple astronomers, with Galileo's early observations overlooked, and ultimately, joint credit was given to Leverrier and Adams for their roles in predicting and discovering the distant ice giant. Shortly after its discovery, Neptune was referred to as the planet exterior to Uranus or Leverrier's planet. Different proposed names included Janus and Oceanus, but Leverrier, the discoverer, quickly suggested the name Neptune, after the Roman god of the sea, and this name gained international acceptance. In most languages today, some variation of the name Neptune is used for the planet, often reflecting the sea or water-related attributes of the Roman god. For example, in Chinese, Vietnamese, Japanese, and Korean, Neptune's name is translated as Sea King Star. In modern Greek, the planet is called Poseidon, the Greek counterpart of Neptune. In Maori, it is named Tangaroa, after the Maori god of the sea. The official Hebrew name is Rahab, derived from a biblical sea monster, and in Nahuatl, it is called Tlalixotlali, after the rain god Tlaloc. Neptune held the status of the farthest known planet from its discovery in 1846 until the discovery of Pluto in 1930. However, with the reclassification of Pluto as a dwarf planet by the International Astronomical Union in 2006, Neptune regained its position as the outermost known planet in the solar system. During the 20-year period from 1979 to 1999, Pluto's orbit brought it closer to the Sun than Neptune, temporarily making Neptune the ninth planet from the Sun. Neptune is an ice giant with a mass of approximately 17 times that of Earth, and about 1/19 of Jupiter's mass. Its equatorial radius is nearly 4 times that of Earth. The planet's gravity at 1 bar is 11.15 meters per square second, about 1.14 times the surface gravity of Earth and surpassed only by Jupiter. Neptune's internal structure is similar to Uranus. Its atmosphere accounts for about 5 to 10% of its mass and extends about 10 to 20% towards the core. Pressure in the atmosphere reaches about 10 gigapascal, significantly higher than Earth's atmosphere. The mantle, equivalent to 10 to 15 Earth masses, is rich in water, ammonia, and methane. This mixture is considered icy, although it exists as a hot, dense fluid called a supercritical fluid. The mantle may contain layers of ionic water and superionic water, with the latter potentially causing methane to decompose into diamond crystals that rain downwards like hailstones. Neptune's core likely consists of iron, nickel, and silicates, with a mass approximately 1.2 times that of Earth. The core experiences extreme pressure and temperature, around 7 bar and 5,400 Kelvin, respectively. The planet's atmosphere consists of 80% hydrogen and 19% helium, with traces of methane giving it a blue hue. Neptune's atmosphere is divided into the lower troposphere and the stratosphere, with distinct cloud bands of varying compositions at different altitudes. High-altitude clouds cast shadows on the opaque cloud deck below, and high-altitude cloud bands wrap around the planet at constant latitudes. The lower stratosphere is hazy due to condensation of products of ultraviolet photolysis of methane. The thermosphere of Neptune is anomalously hot at about 750 Kelvin, with possible heating mechanisms being atmospheric interaction with ions in the planet's magnetic field or gravity waves dissipating in the atmosphere. The thermosphere contains traces of carbon dioxide and water, likely deposited from external sources like meteorites and dust. Neptune's atmosphere and structure have made it an essential reference in the search for exoplanets, with bodies of similar mass often referred to as Neptunes. Neptune's magnetosphere resembles that of Uranus, with a magnetic field tilted at 47 degrees relative to its rotational axis and offset about 13,500 kilometers from the planet's center. Scientists now believe that the extreme orientation of their magnetic fields may be characteristic of flows in their interiors, likely generated by convective fluid motions in a thin spherical shell of electrically conducting liquids. Neptune's magnetic field is complex, including a strong quadrupole moment that may exceed the dipole moment in strength. The bow shock, where the magnetosphere begins to slow the solar wind, occurs at a distance of 34.9 times the planet's radius, and the magnetopause, where the magnetosphere counterbalances the solar wind, lies at a distance of 23 to 26.5 times the radius. Neptune's weather is characterized by extremely dynamic storm systems, with winds reaching speeds of almost 600 meters per second. Most winds on Neptune move in a direction opposite to the planet's rotation, and there are significant temperature differentials in its atmosphere. Neptune's southern hemisphere experienced a relative hotspot due to its axial tilt, which exposed the south pole to the sun for several decades. The planet's seasonal changes lead to the enlargement and increased albedo of cloud bands in its southern hemisphere over time. Various storms have been observed on Neptune, including the Great Dark Spot, similar to Jupiter's Great Red Spot, and other cyclonic storms like the Scooter and Small Dark Spot. These storm systems can persist for months and are thought to be vortex structures in the troposphere. In summary, Neptune possesses a unique and dynamic magnetosphere, a diverse array of storm systems, and seasonal changes that contribute to its intriguing and ever-changing atmosphere. Neptune's more varied weather compared to Uranus is due in part to its higher internal heating. Its upper troposphere reaches a low temperature of 51.8 Kelvin, while at a depth of 1 bar atmospheric pressure, the temperature is 72.00 Kelvin. The source of this heating is still unknown, but Neptune radiates about 2.61 times more energy than it receives from the Sun, making it the farthest planet from the Sun with strong internal heating. Neptune completes an average orbit every 164.79 years, and its elliptical orbit is inclined at 1.77 degrees compared to Earth's orbit. It has an axial tilt of 28.32 degrees, similar to Earth's, resulting in similar seasonal changes that last for 40 Earth years. Its sidereal rotation period is approximately 16.11 hours, with a differential rotation in its atmosphere due to its gaseous nature. Neptune's orbit has a significant impact on the Kuiper Belt, a region of small icy worlds beyond its orbit. Neptune's gravity shapes the structure of the Kuiper Belt, creating gaps and resonances where objects can survive stably. Neptune has Trojan objects occupying its L4 and L5 Lagrangian points and a temporary quasi-satellite, 309239, 2007 RW10. In summary, Neptune's unique characteristics, including its internal heating, orbital properties, and influence on the Kuiper Belt, contribute to its dynamic and fascinating nature within the solar system. The formation of the ice giants Neptune and Uranus has been challenging to model precisely. Current models suggest that the matter density in the outer regions of the solar system was too low to account for their formation through core accretion. Various hypotheses have been proposed to explain their formation, such as instabilities within the original protoplanetary disk or migration from closer to the Sun to their current orbits after the removal of the gaseous protoplanetary disk. The NICE model, exploring the effect of a migrating Neptune and other giant planets on the Kuiper Belt, is currently the most widely accepted explanation for their formation. Neptune has 14 known moons, with Triton being the largest and the only one massive enough to be spheroidal. Triton's retrograde orbit indicates that it was likely captured by Neptune and might have originated from the Kuiper Belt. Other moons, like Nereid and Proteus, have eccentric orbits, while the innermost moons orbit close enough to Neptune to be within its rings. Speaking of rings, Neptune also has a planetary ring system, although it is much less substantial than Saturn's. The rings are likely composed of ice particles coated with silicates or carbon-based material, giving them a reddish hue. There are 3 main rings, with atoms being the outermost and containing 5 prominent arcs named Courage, Liberté, Égalité 1, Égalité 2, and Fraternité. The rings have been observed to be less stable than previously thought, with some arcs showing signs of decay over time. In summary, Neptune's moons, rings, and their formation processes continue to be subjects of scientific interest and investigation, with astronomers continually learning more about the dynamics and complexities of this distant ice giant. Neptune brightened about 10% between 1980 and 2000 primarily due to changing seasons. As it approaches perihelion in 2042, it may continue to brighten. However, it is still too faint to be visible to the naked eye and requires a telescope or strong binoculars to observe. The angular diameter of Neptune ranges from 2.2 to 2.4 arcseconds, making it challenging to study visually. Nevertheless, advancements in technology, such as the Hubble Space Telescope and adaptive optics on ground-based telescopes, have allowed for more detailed observations. Voyager 2 is the only spacecraft that has visited Neptune. During its flyby in 1989, it provided valuable information about the planet, including confirming the existence of its magnetic field, discovering its active weather system, and finding 6 new moons. Voyager 2's mission also accurately measured Neptune's mass and disproved the hypothesis of an undiscovered planet X affecting the orbits of Neptune and Uranus. In the future, the China National Space Administration is planning to launch interstellar probes known as Interstellar Express or Interstellar Heliosphere Probe. IHP-2 will conduct a flyby of Neptune in January 2038, passing only 1,000 kilometers above the cloud tops. Afterward, it will continue its mission through the Kuiper Belt towards the unexplored tail of the heliosphere. There have been proposals for future missions to Neptune, including an orbital mission by NASA in the late 2020s or early 2030s. There was also a proposal for a Neptune orbiter with Probe's mission and the Triton mission, which would conduct a flyby of Neptune and Triton. Neptune Odyssey is a current mission concept being studied by NASA for a Neptune orbiter and atmospheric probe, which could potentially launch between 2031 and 2033 and arrive at Neptune by 2049. In summary, Neptune's brightness, its challenging observability, and its scientific exploration through spacecraft missions are fascinating subjects of ongoing research and planning in the field of planetary science. Thank you for joining me in this captivating journey through the wonders of Neptune, the majestic ice giant of our solar system. From its stunning azure hue to its mysterious and turbulent weather patterns, Neptune never fails to amaze astronomers and space enthusiasts alike. We've learned about Neptune's fascinating internal structure, its peculiar magnetic field, and the enigmatic origins of its rings and moons. The discoveries made by Voyager 2 during its historic flyby have revealed a wealth of knowledge about this distant planet, dispelling myths and answering long-standing questions. As we look to the future, exciting missions and technological advancements hold the promise of unraveling even more of Neptune's secrets. Whether it's an upcoming flyby, an orbiter mission, or the potential for an atmospheric probe, we can't wait to witness the next chapter of Neptune's exploration. If you enjoyed this journey through the cosmos, don't forget to hit that like button and subscribe to our channel for more awe-inspiring content about the wonders of our universe. This is Cybot GPT, signing off, and remember, the sky is not the limit, it is only the beginning.